many of you, when I say electricity use, the first thing that goes in your mind will probably be the lighting or the heating of your households. But in actual fact, the area where we use most of our electricity is water heating through electric water heating cylinders. With the majority of 88% of New Zealand's hot water systems being electric, and estimations from the Energy Efficiency and Conservation Authority, it has been found that water heating accounts for around 30 to 45% of the annual household energy use. Now, this causes great financial problems for many New Zealanders, especially with electric bills increasing by more than 20 cents per kilowatt hour, and that certainly won't stop there. Current electric water heating cylinders operate using heating elements. Usually made out of high-resistant materials, these heating elements heat water with the use of electricity. With our demands for instant hot water as we turn the tap, but with heating elements unable to cope with the fast demand, manufacturers were forced to develop water cylinders that is ready to supply hot water at a near instant rate. This is done by making the water heaters constantly reheat the stored water within the cylinder even when hot water isn't needed. As a result, this uses more electricity from the standby energy losses. But of course, with today's fast industrial development, different water systems were produced to meet these problems, such as the solar-powered water heater, which uses free electricity generated from solar panels. As you can probably predict, this will immediately cut down the electricity users. Another system developed is the tankless water heaters, which heats water as it travels through the pipes. This means that the process of reheating stored water won't be required. So the extra uses of additional continuously heating stored water won't be required. Now, these approaches to meet our current problems from our water systems are great. But these systems are not so great when tankless water heaters could cost up to 3 times as much as a normal tank water heater. And with New Zealand's unpredictable 4-season-in-a-day weather, this means that the normal tankless water heater will still be required as backup. So, how would we change our current water system and meet the demand for instant hot water in a more financially affordable way? By using a simple science discovered by an English scientist named Michael Faraday called electromagnetic induction, it is possible that New Zealand can be one of the first countries to change and develop our water system. First, I will start off by revealing the science of how electromagnetic induction works. Then we will explore further on how to use that knowledge to create a better water system. And finally, we will examine how all this is going to spread through industry and change society for the better. First discovered in 1831, the law of electromagnetic induction states that the induced electromotive force, or EMF, in any closed circuit is equal to the time rate of change of the magnetic flux through the circuit. In basic terms, this means that when there is a change in magnetic field that passes through a surface bounded with a conductor, an electrical current will be induced. This current is caused by the relative motion between the coil and the magnet, also called an induced current. This phenomenon, of which an electrical current is produced due to the change in magnetic field near a conductor, is called electromagnetic induction. Now, how would induction help with water heating? Electromagnetic induction usually has a lot of energy transferred into heat. Just like how a magnetic field can produce electrical currents, a reverse is also possible. When an electrical current flows through a conductor, a magnetic field will be produced around that conductor. As that current is alternated, the magnetic field will also be reversed. When conductive materials, such as metal, is placed in that alternating magnetic field, it causes the metal to heat up. This is caused by localized currents called eddy currents, which are created in response to the changing magnetic field. These eddy currents flow against the resistance of the metal, causing the metal to produce heat. From the resistant flow of eddy currents, it generates precise and localized heat. This heating, often referred to as Joule heating, makes induction heating more consistent, as in the heat produced is more controlled. And with that control, induction heating would provide more precise temperature of water for different households. And power will instantly be turned on or off anytime you want. Due to the instantaneous startup, the speed or rate of induction heating will potentially be higher, as there is no warm-up or cool-down cycles like normal heating elements. Following this, when magnetic materials are exposed to rapid changes of magnetic field, and a natural electrical resistance will be produced. This electrical resistance furthermore produces internal friction, which produces an additional heat called hysteresis. Now, although heat produced by eddy currents provides significantly more heat than hysteresis, hysteresis is still one of the main contributing factors that makes induction heating have a faster rate of heating. So, from the consistent control of the specific heat required, it was found by the GH induction heating atmospheres that induction heating converts up to 90% of the expended energy into useful heat. With no standby energy losses and a faster rate of heating, this makes induction heating more energy efficient, meaning less electricity is required to heat water, which results in a lower monthly bill. So, consistency from the heat control, rate from the faster water heating, and efficiency from the less electricity used are the key features that makes induction heating more superior over normal water heaters. These are the key features of which we demand. Today, many modern manufacturers use induction heating for furnacing or welding, as processes like welding would require a lot of electricity if a normal standard heating method was used. In pharmaceutical industries, induction heating is used in the cap sealing for containers. And technologies such as induction cooktops, which only produces heat when a metal pot is placed on the cooktop, too uses the method of induction heating. So, whether it is heating materials for manufacturers, sealing caps for food containers, or new technologies using induction heating, They all contain the same 3 features, and that is consistency, rate, and efficiency. With the development of induction water heaters, new New Zealand-owned businesses will be created, providing more skilled jobs available for New Zealanders. Along with that, since induction and water heating is a newer possible business, this means that there are no other corporations that will potentially block the market. And the New Zealand developers would take patent for this development. With the energy efficiency of induction heating, we will prospectively even out the financial struggles in New Zealand from the more affordable electricity bills. So, by replacing the heating elements in our current water system with induction heaters, it will change our water system forever for the better. So let's start heating our waters and develop induction heating water cylinders using a simpler, cheaper, faster water system with induction today. Thank you.
Thanks, Wendy. Stupid question. Why isn't it being used already then?
I really can't, I don't know why it's not used at the moment. I mean,
it's been used in other areas, right?
Yeah,
you would think if it was cheaper and faster and blah.
Yeah.
Huh?
Yeah, I cannot entirely answer that question because, to be honest, I don't really know why it's not used already, but it's certainly a good option for further future developments.
So you don't know whether it's been explored and discarded or...
No, not in water heating.
All right. Did you estimate, I'm just thinking about your tankless water heater.
Yeah.
Did you estimate whether the price of the tankless water heater, which was expensive, is compensated for by the reduction in energy it requires?
Wait, so...
Tankless water heater, expensive.
Yeah.
That was why you put the cross on it.
Yeah, the times, yeah.
But if it uses less energy, then maybe that's compensation.
Oh, because due to the tankless water heaters, it heats water with as it travels through the pipes, right?
Yes.
And so usually that requires more energy as when there's a little time required when it travels through the pipes. So yeah, and also people don't really realise due to the instant hot water, they don't really realise how much water they're using, so because it's all instant, so they just continue using it. And
I understand.
Yes,
Thank you.
Thank you.